Let's explore distances on a number line. Find all points 3 units away from 7 on a number line. Well, let's draw it first. Here's our number line. You can only go in 2 directions, so it looks like we're either going to add 3 to 7 or subtract 3 from 7, right? That means the 2 points would be 10 and 4. So there's 2 solutions to this question. Let's look at something different. In general, there is a distance formula for numbers on a number line. It goes like this. If we have any 2 points, A and B, the distance between them is a positive difference between A and B. So in this situation where B is to the right of A, we would do B minus A. But if we don't really know the order of the points, then we have to do B minus A and also A minus B and ask ourselves which one is positive, because distance is positive. The other option is to use the absolute value. If you use the absolute value of A minus B or B minus A, you get a positive result. So you have 2 choices. You either work it out 2 different ways, or you can use the absolute value symbols. If you work it out 2 ways, take the positive answer. So let's use what we know about distance on number lines to find out how many points are the same distance away from 3 as they are from 10. So let's draw it. Let's check each of the regions in the number line. Can a point out here be the same distance from 3 as it is from 10? No, that's not going to work. It's too far from 10. The same is true over here, right? It's going to be too close to 10 and too far from 3. The only way to find a point that's the same distance from both is the point exactly halfway, the midpoint. To find the midpoint, you can just find the average of 3 and 10. Add them and divide by 2. There it is. The number halfway between them is 7.5. That's the only number on the number line that is equidistant from both 3 and 10. So there's only one solution to that problem. This one's really interesting to think about. How many points are twice as far from 2 as they are from 5? Well, let's consider the possible regions on the number line. So here's 2 and here's 5. Is it possible for a solution to be over here? Remember, we're looking for a point that is twice as far from 2 as it is from 5. This one's closer to 2 than it is to 5, so that's not possible. How about in between? Is it possible to put a point somewhere in between so it's twice as far from 2 as it is from 5? How about right about there? Yeah, that seems plausible, so let's try to solve for that. How about beyond the 5? Is it possible to have a number out here that's twice as far to 2 as it is to 5? Yeah, that seems possible. So it looks like there's probably 2 solutions. Let's write some equations and see if we can solve for each of these. Let's call the first one A and the second one B. For the first one, remember the distance from 2 to A is twice as far as the distance from A to 5. So let's write an equation that says that. The distance from 2 to A has to be written A minus 2, because remember A is greater than 2 in this case. That distance is, remember, is and equals go together, is 2 times the distance from 5 to A. 5 is bigger, so I'm going to write 5 minus A to get a positive result. Okay, now we solve for A. If we simplify the right side, we get 10 minus 2A. Okay, well, I'm going to add the 2A over to the side and add the 2 also. Let's see what we've got now. 3A is equal to 12. Well, that's easy to solve. So A must be 4. Let's double check and see if that makes sense according to our diagram. Could this be 4 right here? Sure, that makes sense. It's between 2 and 5. Okay, let's try to solve for b. So an equation for b that still means the distance from b to 2, b is greater than 2, so I'm going to write b minus 2, is twice as big as the distance from b to 5. b is greater than 5, so I'm going to say b minus 5 to get that positive result. Let's simplify. Okay, and get those b's together by subtracting 2b. It's totally fine to move the b over to the 2b if you like doing it that way. So I get negative b equals negative 8. If I divide both those by negative 1, I get b equals 8. Let's see if that looks right on the diagram. Could this be 8 right here? 8 is greater than 5. So now let's check the distances. 8 is 3 units from 5, and 8 is 6 units from 2. Yeah, that's twice as far. And for 4, 4 is 1 unit from the 5 and 2 units from 2. So that also works. Don't forget to check your solutions, because just because you made it work with an algebra equation is not proof that you did it correctly. So it's always important to check constantly to see if our mathematics seems reasonable, and if we can plug it back in and see if it works, that's even better. All right? And that's kind of the beginning of exploring distances on a number line.